How does test uncertainty ratio, TUR, affect test equipment calibration? Imagine trying to measure something tiny with a ruler that has a few missing marks. If your measurement tool isn't precise enough, you might get wrong results. That's where the test uncertainty ratio comes into play. It's a way to see how well your calibration process can tell if a device meets its specifications. The test uncertainty ratio compares the tolerance or acceptable range of the device to the uncertainty in the calibration process. It is calculated by dividing the device's tolerance by twice the expanded uncertainty of the calibration. The expanded uncertainty is a measure of how much the calibration results could vary, usually at a 95% confidence level. This ratio helps us understand if the calibration system can reliably detect whether the device is within its acceptable limits. A high TUR, like 4:1, means the calibration uncertainty is small compared to the device's tolerance. This makes the calibration more trustworthy because it can clearly tell if the device is working correctly or not. When the TUR is high, you can be more confident that the device passes or fails based on accurate measurements. On the other hand, a low TUR indicates that the calibration uncertainty is close to or even larger than the device's tolerance. This makes it harder to decide if the device is within limits. It increases the chance of errors, like falsely passing a faulty device or rejecting a good one. This can cause problems in electrical systems, where precise measurements are essential for safety and performance. In electrical engineering, maintaining a good TUR is vital. It ensures that measurements are accurate and that electrical equipment works within its design parameters. Calibration labs aim for a TUR of at least 4:1, meaning the measurement uncertainty should be at least 4 times smaller than the device's tolerance. This helps prevent mistakes and keep systems running smoothly. Achieving a good TUR involves selecting calibration equipment with low uncertainty and using proper calibration methods. Sometimes, technological advances help improve TUR, but limitations in measurement techniques or device tolerances can make it challenging to reach ideal ratios. To sum up, the test uncertainty ratio is a key factor in calibration. It shows how well the calibration process can distinguish between good and faulty devices. A higher TUR means more reliable measurements, which is essential for electrical systems to operate safely and efficiently. Calibration professionals always keep an eye on TUR to make sure their measurements are trustworthy and their equipment performs accurately.